This video is on section 2.4 and it's on linear functions. So we've already talked about linear equations, and remember back in section 2.1 we looked at an equation that maybe looks something like this: y equals 2x plus 5, and this is a linear equation. We found points for it. Remember, we made a table and we picked values for it. We said we could pick anything we wanted for x, plug it in, and solve for y. So if I fill in 0, I get 5. If I fill in 1 for x, I get 7. And if I fill in 2 for x, I get 9. Okay, and so that's a way we can find solutions to these equations and also to graph them. Now, the linear function is no different from this equation here, except that instead of y, we have f of x. And this is just telling me that it is a function. Remember, y and f of x are the same thing. Okay, so this is the equations we've looked at thus far. You can also find the linear equation written in standard form, where the x and the y are on the same side, equal to the constant. And so the numbers a, b, and c are just real numbers, and x and y are themselves. So notice the difference between the lowercase b and the uppercase b. Okay, they are different. They are both still numbers, but this uppercase b is the coefficient of that y term. Okay, so depending upon which form your equation is in, there is a simpler way to graph that equation. So when it's written in this form, f of x equals ax plus b, or y equals ax plus b, however you want to look at it, it's much easier to just pick values for x, plug it in, and solve for y. When it's written in standard form, it is easier to graph that equation if you use something called the x and y intercepts. The x-intercept is where our graph crosses the x-axis. So if you think about the x-axis and points that are on it, if I'm just looking at the x-axis and I go to any point on that axis, say for instance this point here, if I look at its coordinates are 2, 0. The next point would be 3, 0. On this side, coordinate of this point would be -3, 0, and notice that in all of those points that are lying on the x-axis, that their y value is 0. So in an x-intercept, we always know that the y value is going to be 0 because this point, this intercept, lies on the x-axis. So it's wherever it's crossing that x-axis, and the y value is always 0. Alright, for the y-intercept, similar concept. If I'm thinking about points that are on the y-axis, any point on there, so say for instance this one would be 0, 3, and this one would be 0, -1. And so any point that's lying on that x-axis, its x value is 0, and then the y value will just be wherever it's crossing the y-axis at. So for the y-intercept, alright, it would be x would be 0, and then wherever I'm crossing the y-axis at. Now this is pretty similar to this in that we know one of the values, so it's kind of like filling it into the table. For x-intercepts, I'm going to fill in 0 for y and solve for x, and for y-intercepts, I'm going to fill in 0 for x and solve for y. I know those to be true if I'm talking about intercepts. For x-intercept, the y value is always 0 because that is the y coordinate of any point on that x-axis. And for y-intercepts, I know x will always be 0 because any point on that y-axis has an x value of 0. Alright, so we're going to go through a couple of equations and just look at what form they're in and decide how we can graph them. Alright, so looking at the first one, it is in the form f of x equals -2x plus 6. So it's written in this form here. For these, it's easier to just pick a couple values for x and plug it in and solve for y. And then we can plot those points. And remember, a linear equation, you can fill in whatever you want to. You need, if you're picking points, you really need about 3 good points to graph the equation. just to make sure you're doing your math correctly, your points are lining up. So I'm going to make me a table and fill these values in. So I'll say negative 2 times 0 is 0, plus 6 would give me a y value. And we could also call that, instead of y, let's change that. So instead of y, let's put f of x there. Remember, those are the same. Alright, so then that would give me the point 0, 6. Then I can fill in a 1. So if you're not sure what I'm doing here, I'm saying f of x equals negative 2 times 1 plus 6. I'm just substituting in this x value and solving. And so that'll be negative 2 plus 6, which will be 4. So when x is 1, the function has a value of 4. 1, 4. And then I do the same thing for 2. So negative 2 times 2 is negative 4, plus 6 is 2. Alright, now that gives me 3 good points. I can plot those. So from my origin always, I'm going to go none left or right, but up 6. And then for the point 1, 4, at the origin, I'm going to go right 1 and up 4. And then once again, from the origin, I'm going to go right 2 and up 2. And as you get more points, you should start to see how they are lining up in a straight line. Alright, now remember, this is only 3 of an infinite number of solutions. So if you pick something other than 0, 1, and 2, that is fine. Just make sure that they'll fit on your graph. Okay? So whatever 3 points you get, make sure you go all the way through the points, alright, and put arrows on each end. Okay, let's look at the next one. Alright, this one is written as f of x equals negative 3. Or we could also say y equals negative 3. Notice there is no x variable in there. Okay, so if there's no x variable in my equation, I can't fill in an x variable. I can't fill in a number for that variable. And so what this means is that no matter what value you pick for x, y is always going to be negative 3. So if I made a table, alright, then it doesn't matter what I picked for x. If I picked 0, 1, and 2, y is always going to be negative 3. And so this happens when it just says y equals a number. I don't have the x variable. All I have is the y variable. Alright, so if I were to graph this, I would say from the origin, none left or right, and down 3, 1 right, and down 3, 2 right, and down 3. And so no matter what I picked, if I picked negative 1, negative 4, I would go left 1 and down 3, left 4 and down 3. Alright, you should start to see what kind of line it's forming. Alright, and so what you should get is a horizontal line that passes through where y is 3. Alright, so anytime you see y equals a number, all the x values, doesn't matter what you pick, the y is always going to be negative 3, or it's going to be whatever y or f of x equals. Go to that point on the y-axis and draw you a horizontal line. Okay? So anytime you see y equals a number, or f of x, whichever one you want to use, that's going to be a horizontal line. Alright? Let's look at the next one. Okay, this one says x equals negative 3. Notice there's no y value, there is no f of x. So this is just x. So what this one is saying is that no matter what you pick for y, x is always going to be negative 3. And so you can pick whatever you want to for y. X is always going to be negative 3. And so if I were to go graph that, I would go left 3 and none up or down, left 3 up 1, left 3 up 2, or I could go left 3 down 1. Alright, and then when I graph that, you should start to see the points are lining up to form a vertical line. Alright, and so anytime you see just x equals a number, alright, then I know I can go to that number on the x-axis and draw a vertical line. Okay, so let me say that again. Anytime I see x equals a number, there's no f of x, there's no y, just x equals a number, I know this is going to be a vertical line. So I go on the x-axis to wherever that number is, and I draw a vertical line. So let's say if said x equals 4. So if that were my equation, I would find 4 on the x-axis. I can simply go there and draw me a vertical line. And then any point on that line has an x coordinate of 4, alright, and the y values will vary. Alright, lastly, alright, what I want to do on this one, I want to change this one. So instead of minus 5y, let's mark that out, and let's do 6y, and instead of 0, let's make it 12. So your equation should say 4x minus 6y equals 12. It should look like this. Okay. Now, this equation is not in the form that we have been accustomed to using. Notice it is in standard form, where the x and the y are on the same side. So when that happens, it's easier to graph it using the x and y intercepts. Alright, now to find the x-intercept, we know that y is 0. So if I take, for the x-intercept, so this is where the graph is going to cross the x-axis. If I take and I plug in 0, alright, I'll have 4x minus 0 equals 12. Well then 4x minus nothing is just 4x. Alright, and that will tell me that x is 3. So the x-intercept is going to be at the point 3, 0. Remember, we filled in 0 for y. Okay? The next y-intercept, alright, we said the y-intercept, every point on that y-axis has an x value of 0. So if I fill in 0 for x, 4 times 0 minus 6y would give me negative 6y equals 12. Y equals negative 2, so that'll give me a y-intercept of 0, negative 2. Alright, really, when you're filling in that 0, really what it does is takes that term out. So if you think about the x-intercept, what's happening is that y term is going to go to 0 every time. So you end up with just 4x equals 12. The y term is gone. And for the y-intercept, when you fill in that 0 for the x, it really just takes that x term out of there. And so you'd just be left with negative 6y equals 12. So for the x-intercept, you can say 4x equals 12, solve for x. For the y-intercept, cover up your x, and you'd have negative 6y equals 12. Alright, so you don't have to go through all this work if you can recognize that that always happens. Alright, so now what I'm going to do is plot my two intercepts. This is the x-intercept. It should be on the x-axis. So from the origin, I'm going to go right 3 and up or down 9. And then back from the origin, I'm going to go right or left none, but down 2. Alright, then I should be able to connect these 2 points. Make sure you go all the way through them and put arrows on each end. This tells me that this continues on in both directions.